Example 2. An ambulance is traveling at 70 kilometers per hour toward a stationary car, the detector or the observer. The frequency of the siren is 750 hertz. What is the frequency detected by the observer or the detector as the ambulance approaches? Air temperature is 1 degree Celsius. So let's start out by highlighting some givens that will be important for working on the question. So we are given a speed, and there are a variety of speed variables in this equation. So which speed are we given? It says the ambulance is traveling at 70 kilometers per hour. So the first thing is maybe drawing a diagram to interpret the givens if you don't already know what that given is. So we have our ambulance here and the siren. The siren is the wave source, and the ambulance is traveling to the left. So that means that the crests are more bunched up in this direction than the crests in this direction because of the Doppler effect. So these crests are a higher frequency. So we've got the ambulance traveling 70 kilometers per hour toward the stationary car detector. The frequency of the siren on the ambulance is 750 hertz. So 750 hertz is F. Now, is it F observed or F original? That is the siren, so that's F original is, I'm going to try and write this as neatly as possible, 750 hertz. And then we want to know what is the frequency detected by the observer. This is the Doppler effect equation, and that is what we are solving for. We have the original frequency, then let's ask ourselves, what else do we have in this equation? Do we have the speed of sound? Well, we have the air temperature. So let's go back to looking at the givens. We do have the air temperature. It says a stationary car. Stationary means something. Stationary means one of the V's is going to be 0. The frequency of the siren is 750. What is the frequency detected by the observer? So we have several givens, and what we're trying to find is the frequency detected by the observer. So given the air temperature, we know we have our equation V equals 331 meters per second plus 0.606 meters per second per degree Celsius, 1 degree Celsius. So the speed of sound is, let's get out my calculator, 33.1 plus 0.6 is 331.6 meters per second. So this is something that we know. Do we know V of the detector? So the detector or the observer is stationary. That means that this whole term goes to 0. Do we have V of the source? We do have 70 kilometers per hour, and we are going to convert it first to meters per second. Oops, I was pressing a button. Meters per second so that they're compatible units. So the speed of the source is equal to 70 kilometers in 1 hour. And how do we convert that to meters per second? Well, 1 hour we want to get rid of. And since hours is on the bottom, I'll put hours on the top. 1 hour is equivalent to 3,600 seconds. And then we want to get rid of kilometers, so we're going to put kilometers on the bottom, and 1 kilometer is equal to 1,000 meters. So V source is equal to 70 divided by 3600 times 1000, which gives us 19.444 meters per second. We're not going to round it. We're going to keep quite a few digits. So we have everything on the right side, and we can solve for the observed frequency. So let me just change color here to see if it's more clear. I'm not quite sure what to do when I have to scroll down in this program, but we will see what happens. The observed frequency is equal to speed of sound at that temperature, 331.6 meters per second, plus 0 meters per second divided by 331.6 meters per second, plus V source is 19.44 meters per second. And then that is going to be times 750. Now hang on a second. We're going to do a common sense check. If the siren is moving towards the observer should hear a higher frequency. If we have a plus sign here in the denominator, that's going to give us actually a smaller observed frequency. So actually, let's go back to get the eraser. And then, oh, whoa, that was not the tool that I thought it was. No worries. Where's edit, undo, edit, undo. Okay. Let's pick an eraser size that's more appropriate for our mistake. Small eraser for small mistake. And then how do I go back to pen? Let's do it in green so we can correct it. So we have a 0 here, but we have a negative 19.44. So 331.6 divided by 331.6 plus, or sorry, subtract 19.44, hopefully answer button, because hopefully we've kept that, times 750. And we get an answer of 796.7 hertz. And that is two significant figures. That would be 8.0 times 10 to the 2 hertz for the observed frequency. So that is our final answer.